Hello, I'm Justine Lu, and today we will be discussing about organic chemistry. Big question is, what is organic chemistry? Organic chemistry is the study of structure, properties, composition, reactions, and preparation of carbon-containing compounds, which include not only hydrocarbons but also compounds with any number of other elements, including hydrogen, nitrogen, and oxygen. Hello, I am Justine Lu, and today we'll be talking about organic chemistry. Today's lesson will be about organic compounds, aliphatic, alicyclic, and aromatic. So what are organic compounds? Organic compounds are any of a large class of chemical compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, most commonly hydrogen, oxygen, or nitrogen. There are two classifications of organic compounds. First, there is aliphatic, and second is aromatic. First, let's discuss aliphatic. Aliphatic compounds are simple, complex, long carbon chains. This includes carbons such as alkanes, molecules such as alkenes, which possesses a carbon-to-carbon double bond, and alkynes, which possesses triple bonds. There are two types of aliphatic hydrocarbons. They are saturated and unsaturated. Saturated hydrocarbons have single bonds between carbon atoms. Unsaturated hydrocarbons have one or more multiple bonds between carbon atoms. Now there are also two types of aliphatic compounds, an open chain and an alicyclic. An open chain has carbon atoms arranged in a linear rather than a cyclical chain. Unlike alicyclic compounds, those are which have a cyclic as well as aliphatic chain attached to the cycle. Now let's proceed to the alkyl groups. An alkyl is a functional group of an organic chemical that only contains carbon and hydrogen atoms, which are arranged in a chain. There are three classifications, which is alkanes, alkenes, and alkynes. Alkanes are organic compounds that consist entirely of single bonded carbon and hydrogen atoms and lack any other functional groups. Alkanes have the general formula of C sub n, H sub 2, n plus 2. You also need to take note of the prefixes used in IUPAC system to show the presence of 1 to 20 carbon atoms in an unbranched chain. Here's the chart for the prefixes needed in naming carbon atoms. And then we have alkenes. Alkenes are a class of hydrocarbons that are unsaturated compounds with at least one carbon-to-carbon double bond. Another term used to describe alkenes is olefins. Alkenes are more reactive than alkenes due to the presence of a double bond. The general formula for alkenes is C sub n, H sub 2, n. Next, we have alkynes. Alkynes are organic molecules made of the functional group carbon-to-carbon triple bonds and are written in the empirical formula of C sub n, H sub 2, n minus 2. They are unsaturated hydrocarbons. Now I'll be giving an example of an alkane. Here, this is the first example of an alkane. This is written in the expanded form. This is actually known in the common name as an ethane. And when named in the IUPAC system, it is also ethane. This is named as it is since it has two carbons in a single chain. Now here's the example of alkenes. This is a skeletal formula of butene. And when named in the IUPAC system, this is known as but2-ene. This is referred to as but2-ene because it has 4 carbons. And when we're looking back at the chart of the IUPAC system, the number of 4 carbons is named with the but. The next one is 2 because it has a double bond on the second carbon. And the last prefix is "-ene" because this is an alkene, since it contains one carbon-to-carbon double bond. resulting to the name butene. As for the common name, butene. And here we have alkynes. This is an example of an alkyne. This is the condensed form of the common name ethyne. This is named in the IUPAC system as ethyne. It is named as it is because it is only holding 2 carbons within the chain. Ines, since it is holding a triple bond within the chain. I will also be showing an example of alicylic alkanes, alkenes, and alkynes. Let's go with the first one. This is an example of a cyclohexane, which is considered as an alicylic alkane. It is named cyclo since it is a closed chain. Hex because it has 6 carbons, and ane since it is considered as an alkane. And for the cycloalkane, it has a single bond towards each carbon atom. Now here's an example of an alicylic alkene. This is a cyclopentene. This is referred to as cyclo because then again it is in a closed chain. Pent because it has 5 carbons present. And ene because it is considered as an alkene, which means it has a double bond within the chain. And here we have an alicylic alkyne. This is known to be as a cyclopentine. Cyclo because then again it is an enclosed chain. Pent because it has 5 carbons present. And with the prefix "ine" since this is an alkyne because it has a triple bond present within the chain. And the last example would be an aromatic alkane. This is an illustration of a methylbenzene. And what you have to take note is that a benzene always has 6 carbons present. And this is called a methylbenzene since it only has 1 attachment. Therefore, the name methylbenzene.